Hi, folks. Here we are, the first lesson of Math 9. I know it's 2.1, but we do start on Chapter 2. And the reason that I do this is, I guess, so that I can be in two places at once, so that I can give the lesson and walk around to make sure that you folks are all right and answer any questions if you have them. And also so that if you're away or if anybody's away, they can watch this and still get the information, or a parent or guardian or friend or EA could watch this and still have the notes. So the first section I'm going to do, I'll highlight the fill in the blanks that I'd like you to fill in. And I have another kind of notes part here. And hopefully it won't be too long. I think my notes were a little long in Math 9, so I'm Math 8, so I'll just try to keep it a little bit shorter. And now I've already talked for a minute. Anyways, some terms before we start. So a power is, and I'll highlight as we go, is a base number with an exponent. So for example, 5 to the power of 3, where 5 is the base and 3 is the exponent. So 5 is our base, 3 is our exponent, and the whole thing is a power. So a power is used to represent repeated multiplication. I'll go over this again in the next part of the notes. But it's a way, for example, so instead of writing 3 times 3, we can write 3 squared, or 3 to the power of 2. The bigger number in the power, the 3 right here, is called the base. And it is the number being multiplied. The smaller number in a power, the 2, so we're talking right here, the 2 is called the exponent. It tells us how many times the base is being multiplied by itself. So these highlighted ones are the ones where I put the blanks for you, so make sure you're filling in these blanks. I did try to blank out important words, so if you don't fill in the blanks, it might not make sense. So try to follow along and fill in the blanks. So if a number does not have an exponent, like 5, for example, just 5, there's always an imaginary 1 as the exponent, so that it reads 5 to the power of 1. And this simply means that the 5 is not being multiplied by any other 5s. I do have a thing in my classroom. If you notice above the whiteboard, I have a bunch of kind of invisible math rules, and this is one of them up there. So for example, 5 times 5 times 5, the repeated multiplication is the same as 5 to the power of 3. So the base is 5 and the exponent is 3. And this whole thing is called a power. The base is 5 and the exponent is 3. If we have 7 times 7 times 7 times 7 times 7, or 7 to the power of 6, the base is 7 and the exponent is 6. That's a number of times it's being multiplied by itself. And remember, the whole thing is called a power. There are some rules that we need to know for the powers of negative numbers. So if a power has a negative base in brackets, we treat it as the same as a positive power. So for example, if we're looking at in brackets, -3 times -3 in brackets, -3, -3, we write it, sorry, I should scroll up, as -3 to the power of 4. So the brackets are super important when we're talking about powers. Okay, let me get my second page of the notes here. Make sure there we go. However, if the base is negative but does not, highlight please, does not have any brackets around it, we do not include the negative each time the base is multiplied by itself. So let me show an example. So example, -5 to the power of 4, the negative 5 is not in brackets. We treat this as a negative outside the brackets of 5 times 5 times 5 times 5. Okay, so this, if it had brackets, it would end up being like -5 times -5 times negative 5. Oops, negative 5 times negative 5. Wow, really not. There we go. Times negative 5 times negative 5. But because it doesn't have those brackets, we draw it like this. So let's evaluate or solve some positive and negative powers. To evaluate a power, we simply multiply the base by what the exponent tells us. So here's some examples. 3 to the power of 2 means we have 3 times 3 twice. So there's 2 of them. And 3 times 3 is 9. Here we have 5 to the power of 3. So we're multiplying 5 by itself 3 times. 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. Here we have 2 to the power of 3. So we have 2 being multiplied by itself 3 times. 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. And here we have in brackets negative 4 to the power of 2. So we have negative 4 times itself. And a negative times a negative is a positive, so that's 16. Here again, we have a negative 3 in brackets to the power of 3. So this is a negative 3 times itself 3 times. So negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is a positive 9. And positive 9 times negative 3 is negative 27. And then now we have negative 5 to the power of 3, but there are no brackets. So this negative remains on the outside. So we have 5 times 5 times 5, which remember from up here is 125, but the negative goes with it. So negative 125. Now we have a negative outside of a bracket negative 4. So we do have to show the repeated multiplication of the negative 4, but then we also have the negative on the outside. So let's do this first. Negative 4 times negative 4, positive 16 times negative 4 is going to be negative 64. Is that right? 16 times 4. Yes. But this is a positive, this is a negative, so negative 64. But then we can't forget this negative on the outside. So it would look like that. So it's actually going to change it into a positive. It's going to be a positive 64. These, remember, subtracting a negative is the same as adding a positive. So we're just going to count this as 64. Let's look at the next part of the notes. We're going to label this. Remember, the whole thing right here is called a power. This one right here is called our exponent. And this 5 in this case is called our base. So if you label that, that would be great. So this is all a compact way of showing repeated multiplication. So, for example, the mass of Earth, if you take physics, Earth, is 597,000,000, and there's 22 zeros. But we can write this as 5.97 times 10 to the power of 24. So it saves us writing 22 zeros. And the reason it's 20 to the power of 24, not 22, is because we've also moved our decimal point over. So try to complete this chart on your own, and then I can come back and help you folks with it. So I'm going to pause this. Try to do this on your own. I can do the first one with you. So here we have the power, the whole thing. The base is the big number that's being multiplied by itself. The exponent here is 4. Let's draw this as repeated multiplication, 4 times 4 times 4 times 4. And in standard form, what's the solution? This one I know to be 256. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4 is 256. So let's do the rest of the chart. I'll pause the video. Okay, hopefully I paused the video. So let's do the next one. The base, again, we have is negative 10. The exponent here is 3. As repeated multiplication, we would show this as negative 10. Remember, it's in brackets, times negative 10 times negative 10. We end up with negative 10 times negative 10 is 100, times negative 10 is going to bring us to negative 1,000. Let's look at the next one. We don't have the power, but we do have the base and the exponent. And it's negative 6, so let's put it in brackets, negative 6. The power is 2. For repeated multiplication, negative 6 times negative 6. And in standard form, negative 6 times negative 6 is going to be a positive 36. Finally, here we are. We have a 1 as our base. It looks like it's being multiplied by itself 5 times. So we got 1 to the power of 5, and that's just 1. Next, I'm going to get you folks to do this on your own as well. This wants you to write each product as a power and then evaluate or solve. So this one's 6 times 6, it's 6 to the power of 2. And if we solve it, 6 times 6, or 6 to the power of 2 is 36. Let's write this as a power first. We've got a base of 3. It's being multiplied by itself 1, 2, 3, 4, 5, 6 times. And if we solve that, you get 729. So let's try the next ones. Let's be aware of our brackets or not brackets. And I can help you with that, folks, when you get back. Okay, here we have base 10. It's being multiplied by itself 4 times. So 10 to the power of 4. And that's going to equal 10,000. So that's a 1 with 4 zeros. Here we have a base of 8, and there's a negative, but no brackets. And it's being multiplied by itself 3 times, so it's going to look like that. That's going to equal 8 to the power of 3. So 8 times 8 times 8 is, I think, 512. Is that right? 8 times 8 times 8. Okay. And let's not forget our negative. So negative 512. This one we do have brackets. So our base is negative 8, and it's being multiplied by itself. It's not a very good bracket. 3 times. And again, this ends up being negative 512 because we have a negative times a negative, which is a positive, and then times a negative, which is going to be a negative. This one, we do have the base of negative 8, but we also have that negative in front of it. It's being multiplied by itself 3 times, so it's going to look something like this. So we will end up with the negative 512, but this negative on the outside is going to cancel it out. So we're going to end up with 512. Let's look at the last page. Maybe you folks can answer this on your own, and then I'll answer it with you. So is the value of negative 2 to the power of 4 different than the value of bracket negative 2 to the power of 4? Explain. So try to explain this in your own words. I'll hit pause here. Okay, so the answer is yes. This one is going to look like this. Negative 2 times 2 times 2 times 2. So that gives you 16 with the negative on the outside. So negative 16. But this one is going to be negative 2 times negative 2 times negative 2 times negative 2.